Well, hi, thank you for coming to this talk and hearing me blather on about Rust. The structure of the talk will be a general overview of where Rust is at in 2025. It's been 10 years since the stable release, 1.0 of Rust, and I figured it was maybe a good time to revisit the topic. And we'll look at some available options for cross-platform app development with Rust and compare with code a couple of prominent GUI frameworks. There's going to be a disappointing lack of audio code. I got some feedback from a run-through, a version of this talk that I did last week at a meetup, that it would be nice to see more audio stuff. Unfortunately, I didn't find space. So you're going to have to expect very little actual audio stuff. But there is extra detailed content if there's time at the end. I'm not sure exactly how long this will go. I'm going to try and leave as much time as I can at the end for Q&A. And if there are certain topics that you'd like to go into a bit more detail on, then I've got a few slides at the end that maybe can help. And a bit about me. I'm a software engineer who I like making music software and audio software. I was born in Bristol, so I'm very happy to be here. I came last year and had a great time, very happy about it, so I figured I'd come back. It's nice to be here, and currently living in Berlin. In 2018, JB mentioned this earlier, I gave a talk at ADC about Rust. It was quite early days for the language, and it was interesting to explore it from the point of view of, is this a viable alternative to using C++, which is, of course, the mainstream language for development of real-time audio software. And you can find this on YouTube. And this is serving as a bit of a follow-up from that talk. 7 years later, how are things looking? In the year after that, I left my job working at Ableton, going to freelancing, consulting, and in 2020, as one of my steps going deeper into Rust, I started an open source scripting language project, which kind of serves as something along the lines of Lua for Rust, which I'm still working on, and it has not really anything to do with audio, so I won't talk any more about it, but it's nice to plug it. And since then, worked with a few different companies, been consulting, working with different clients, and then now I'm excited about making music software again. After not really having it as my main focus for a while, I'm quite keen on making it my main focus again. So, it's worth having a quick Rust refresher. I think at this point, most people are familiar with the basics, so that roughly speaking what Rust is, but it's useful to have some common ground to work from. So just so that we have the context. So I'll go through it as quickly as I can. We have a language that has very similar goals to C++, in that it is a system-level programming language intended for having direct control over the system resources, the hardware as close to the hardware as possible, while building on the lowest level with high-level abstractions that are aiming to make programming easier, and with the goal of these abstractions being as close to zero cost as possible. So far, very similar to C++. One of the main differences is that it has a very strong emphasis on safety, and you'll hear safe or safety brought up a lot. And just a quick overview of what exactly that means, or at least how I look at it. The compiler has lots of safety checks baked into the type system and the borrow checker. You'll hear a lot about this kind of system that makes sure that your code is adhering to certain rules and restrictions. Undefined behavior is just avoided whenever possible. It's really just they do everything they can to avoid it. avoid accidental memory accesses by default. Like this is one of the big features that you don't end up accessing memory that was deallocated or accessing memory that no longer should be. You don't run into the situation where one part of your application is modifying some state without you being aware of it. If you have a reference to some data and you're able to mutate it, you have a guarantee that no other part of your application is also mutating it. And there are also thread safety guarantees built into the type system where you have certain guarantees and restrictions enforced at compile time. For example, if you have a value type where you can only keep it on your particular thread, you can enforce through the type system that it can't be transferred to another thread, for example, which is a very nice thing. You also have the ability to escape from these safety restrictions with the unsafe keyword, which allows you to bypass most of these restrictions. And then the general pattern is that you have some core unsafe logic, which has a safe API built around it so that you have a safe interface to work with something that is internally unsafe. For example, the VEC type, which is the dynamic array type in the standard library, has lots of unsafe code internally, but the API for it is completely safe. And then to be sure that it's completely safe, you need to audit this logic. And when you're reviewing code or like you're looking for the source of a weird bug that's occurring, then your unsafe code is usually a good place to start, which makes reviewing your code base or managing like more complex logic easier. So that's a key difference. And then I think one of the main reasons for its popularity, I think it goes beyond that. One is that there are lots of great defaults in the language, like the design of the language has a lot of good thinking gone into it. And one thing is that you have some types at the heart of the language. In Rust, this is enum, std variant is maybe the C++ analog. This is at the very core of the language, and the ecosystem is built on top of it. Const by default is something that I'm very much a fan of, and if you want to mutate a value, you need to opt into that. And result-based error handling, I'm also a big fan of. It makes following application logic much easier to reason about when you can see exactly where the exit points and where your potential errors are occurring. I think an even bigger explanation for the growing popularity of the language is that the tooling is also awesome. RustUp is the standard toolchain installer manager. So if you want to get started with the language, you'll be going and installing RustUp first, and then this will be used to install your compilers and your compilation target support. And that installs for you Cargo, which is the standard build tool and package manager, and Crates.io is the standard package repository. Where everyone publishes their libraries, or crates. It's just a package or a module or whatever. It's just the rusty word for it. And docs.rs is a website where you get automatically generated documentation for all of the crates that get published to Crates.io. And the really nice thing here is that you see standard used here a lot. It's that these tools and platforms were built up alongside the language from the early days, and that means that the entire ecosystem is using these things as standard, and that means there's the network effect of these things being more and more valuable as more and more people use them. And then they're not mandatory, so you can roll your own build tool if you want, and some companies do. And of course, it's not perfect. I don't want to try and sell you on Rust as a fix everything language that is a magic bullet. It's not. It's a tool, and it has imperfections. And if you get into it, you'll find your pet things to get annoyed about and complain about. And I'm not really going to get into it now, but you can poke me later and see what I come up with. But I mean, I could spend a whole talk whining about things, but I guess that's not really what you want to hear. But the nice thing is that get the language has the ability to evolve because they committed to a system of additions early on. And an addition is a version of the language which can include breaking changes, and then they are opt-in. So you can say, my code will use the latest edition, but maybe my dependencies will use an older edition. The compiler is able to compile your dependencies in the older edition, and so then you have backwards compatible evolution of the language, which is awesome. And if you get into the language, you'll find lots of features that you wish were stable. Work in progress features that haven't made it to the stable edition of Rust yet, nightly only, meaning every night they generate like the bleeding edge version of the toolchain, the Rust toolchain, and unstable features are worked on, and you have access to them through the nightly channel, but then you're restricted to using the nightly channel rather than stable, which maybe is a problem, maybe not. I think practically speaking, a lot of companies will just choose to use a nightly version and then they get access to all the features they want while accepting the chance that they might change over time. And for a last bit of context, a bit of history, the language started in 2006. First public release was in 2012. And then the first stable release, as I mentioned earlier, was in 2015. And I think it's worth pointing out here that 3 years is an extremely fast timeline to be like moving to a stable release. I find it very impressive that they managed to do this. My read on this is that stability was seen as like a fundamentally important thing to achieve, and they managed it. And then since then, they've had every 6 weeks a stable release, leading to now we're at 1.91, which is good progress. It shows a lot of progress, and there have been tons and tons of changes coming in over the years that have made the language much nicer to use. Like you get new treats every 6 weeks. So where is Rust at in 2025 in particular for audio development? Well, it's used widely in production, but maybe not so much for audio, but it is used widely in production in some areas. So command line tools, people are very happy building shiny new tools for the command line in Rust. Maybe some of you are already using some that have been built with Rust. There's like a lot of traction there. In networking infrastructure, lots of people are doing web programming and server programming and networking logic in Rust. If you're in the security domain, people naturally have been very attracted to the safety guarantees. And in embedded systems, the safety guarantees also generally lead to a certain amount of stability, which is important for a system that's running in a closed box. Something to notice here is that these are all kind of low-level, platformy, infrastructure-y kinds of tools, and you're not really seeing anything like a full-blown app. And that kind of tracks with my experience as like a consultant over the last few years, where I've been looking for opportunities to work with Rust and clients who are interested in using it. A notable example was the haptics company based in Berlin called Lofelt, who were working on advanced haptics and still do post-acquisition at Meta Reality Labs, where they're working on the haptics SDK that's used for generating high-quality haptics for like games and apps that are using like Meta hardware. So the app that you see here is an Electron front end, and then like things like the audio analysis algorithms are implemented in Rust, and then the export into the SDK, and then the runtime of the engine. Much of this is built with Rust, which is neat. Another client I worked with, Super Hi-Fi, who work on internet-based radio services, and like they have needs for lots of offline audio processing, and they were quite happy about buying into Rust for that work, where the dependencies are small, so it's quite easy to slot in. Like this is a situation where it makes a lot of sense to try out using a different language. which I think they did with success. Another example that I was reminded of from the previous talk on granular synthesis was a granular synthesis engine I wrote in Rust, which ended up in an art project that might still be running somewhere in Austria, in like a sort of art castle where they have this like mechanical alien-looking ball thing, and it like generates like crazy noises with granular synthesis. And yeah, that's Rust, and that would have been a great slide, but I was only just reminded of it, so you'll have to use your imagination for that. Now, a question that's asked in the Rust ecosystem often is, are we X yet? And X being any particular domain. And in this case, the thing that I'm pointing out as missing a little bit is like the use of the GUI. So the question of, are we GUI yet, is explored on the website arewegui.com. And their take on the question, well, they give an overview of all of the ecosystem. They have like links to, like categorized links to like major libraries, crates. And their headline is that the roots aren't deep, but the seeds are planted. And I think this is a pretty fair take. It's like there's lots of effort going into trying things out and like planting seeds, but it's still early days, and you know, things are still relatively young. An explanation for why this is maybe lagging behind other areas, which have like seen like much more advanced use and much more traction, is that a typical explanation for this is that like traditional object-oriented patterns for building a UI framework, although technically possible in Rust, are maybe not very ergonomic given the restrictions of the language, and maybe it's going against the grain a bit. So typically projects have been looking for other approaches, like different ways of managing data and having data flow through your UI. And there have been lots of these projects, like dozens and dozens, trying different directions, different approaches, and some have like made a lot of progress. Some like tried and it maybe moved on to something else. Earlier this year, there was a great article. Someone did a survey of I think every GUI library listed on arewegui.com, and then tried building an app with every single one of these frameworks, and then has like a very long article, like lots of detail. Like it's a good read if you're interested. And then recently at RustConf, there was a lightning talk from somebody, one of the engineers who works on the Z editor, like the code editor that maybe some of you have seen. This, they're using Rust through their whole stack, and they have their own UI framework. And the argument being made there very roughly was that building a GUI is not really what people need when they look for a GUI framework. What they really need is an application framework, and there's a lot more to an app framework than just the GUI. And you have to think about much more than just the widgets that you're putting on the screen. And I think that's maybe a better explanation for why there isn't like a compelling app framework yet with Rust. And it's just because it's such a huge task to actually build something that is covering all of the needs that you have when you want to build a complete app, especially one that's cross-platform. But people are doing it. So there's Rerun, which is like a data analytics platform, and they're using eGUI. I think the main developer of eGUI is now one of the founders of Rerun. So there's like some commercial backing for the development of this framework, and they're really buying into it, and they seem quite happy. Iced is a framework that has gained some traction in the Rust audio community. It's like quite a popular choice for making plugin front ends. And Slint is a commercial framework from some Execute people who, one of their showcase examples is this editor made by Wes Audio for one of their hardware products. And this is using their framework. So it definitely seems like it's happening. If you have the interest to like dig in and maybe write some of the frameworks yourself, then it's certainly of course possible. And it does seem like things are actually going in that direction now. So then the question I wanted to ask for myself, if I was going to be building like music apps, then would I use like a Rust framework or a Rust stack through the whole stack, Rust through the whole stack? And to explore that question, well, let's see. The most pragmatic answer to this question, if you want to use Rust, let's say for your audio engine, but then how do you deploy that? The most pragmatic choice has been over the last few years, use Rust from other languages and frameworks. And this is kind of what I was showcasing in the previous talk, that it's possible to do this. And over the years, it's become easier to do this with better tooling for generating bindings and so forth. So you could use Juice as your application framework, or Flutter or React Native, or you could take the approach of leaning into the standard platform framework on a per platform basis. But so then why do I care about trying to use Rust through the whole stack? And the main answer for this is to minimize context switching. And I think everyone has a maximum languages per stack threshold. And mine is around 2 to 3. So minimizing the number of languages in your stack is a worthwhile goal. And I'm coming from the point of view of Rust being my sort of daily driver language, and it's my preferred language to use in most cases. So having that at the core, and then where possible, using it throughout. And then if there are needs for other languages to integrate in it, then sure. But starting with the question of, is it even possible to just have Rust through the entire stack, is worthwhile, at least it's worth asking the question and investigating a bit. So the plan for doing this investigating that question, is to build a very simple audio app in various Rust app frameworks, and to spell out what I think is different from an audio app to any other app. You have this real-time audio stream running with a processor. You have some real parameters that you need to tweak that get sent to the audio processor. The processor responds, it processes audio, and it can send some data back to the front end, whatever that might be, but some real-time data gets back to the UI, and then the UI can visualize that data somehow, and then run the app on as many platforms as the framework supports. Which brings me to Freeverb, which is the processor or the algorithm that I was talking about in my previous talk 7 years ago, so I'm not expecting you to remember, but I demoed it as a useful algorithm to treat as an example, because it's very simple, structurally very straightforward, and so not that much code, and so it fits on a small number of slides, which is why it was a good example back then. And my Rust port is online on GitHub. And there's a picture of the structure. That's all of the audio stuff you're getting. I'm not going to, if you want to see the DSP, you can look on GitHub. It's so simple, it's barely worth mentioning. The point is that for this purpose, it has a very small parameter surface, which makes it viable for reproducing in multiple frameworks. So a few sliders for floats and a couple of Boolean toggles, and then, if possible in the framework, visualization. So this is the sort of layout that we're aiming to produce. As a bit of groundwork, we need some parameters to plug into the UI. So we have some float parameters and some bools, and a basic interface for getting useful information from the parameters, like name and whatever. This isn't meant to be some kind of production grade parameter abstraction. It's just for the purposes of hooking up this demo. We have an interface, a trait for sending messages to the processor, and another trait for receiving messages from the processor. So push message here is, let's say, a lock-free channel that can send messages down to the audio processor, and then in return we have another channel. But on some platforms, maybe we're going to use a different channel type, which is why there's an interface for this. And an audio stream. And this is generic on the module type. You see these brackets with the M. This says that anything that implements audio module can be used by this audio stream. This could just be a free verb module to make things simpler, but I figured I'd leave the door open to trying other kinds of processes out later on. You have a new function which returns like the stream. If successful, you see the result type there. It means that it could fail, like if for some reason accessing the audio hardware doesn't work out. And you have a toProcessor function which returns a sender and a fromProcessor function which returns a receiver. And with that, we have enough to get going and build an app. First framework we'll look at is eGUI. And eGUI has this nice online demo. It's like this is running in the web, but it also runs on desktop and wherever else. It's an immediate mode framework. It's very popular as an embedded UI, so it's a bit like a Deer image UI for like people who are like familiar with it in C++. It's a very similar idea. But it also has a companion app framework called eFrame, which allows you to spin up an app account for windowing, and it manages the event loop for you, tightly integrated into eGUI being the main UI framework. And let's see, is this going to play? Yeah, so there's no sound, but you can see that this is actually the UI, and this is built with eGUI. These are basically standard widgets, so I didn't really do any styling here. But you can see that it at least works. Maybe, and then we can see how it's hooked up. So you have a main function. Do you actually see my cursor here? You do, okay. Yeah, so we have like a run native function from eFrame. So this is the entry point into your application. You pass in some options. So in this case, we're going to set the window size. And then you say, here is my app. And then it runs. And that's, you know, all of the logic is hidden away from you from that point. And you then have an update function for your app, which we'll get to in a second. You have first of all, you set up your struct so that it has its internal state, like some UI state. You have your audio stream, which in this case is wrapped in an option, so it might be there, it might not be. You have a new function again that might fail, and you have a toggle audio stream function, which we're going to trigger from the enabled switch in the UI. And then the update logic happens in an implementation of the eFrame app trait, which has an update function. And this gets called every time the window wants to update. So this is like, you know, maybe 60 frames a second or whatever, like if your app is continuously updating, or or less frequently if updating isn't necessary. What we're going to do here is receive messages coming from the processor. And then we're going to start laying out the UI. Because this is an immediate mode framework, we're doing things very procedurally, and like this needs to go here and that needs to go there. It's very to the point, which I appreciate. We're putting in a label with a certain style, and then this is a block of code that's saying we're going to lay this widget out with right to left ordering so that the enable button gets pushed over to the right. The more interesting part of this is that the checkbox takes a just a Boolean, and then you declare it and also check if it has changed in the same step. So checkbox returns a response, and then you can check on that response, has the value changed? And in this case, it has changed, so then we're going to call toggle audio stream. Now, what you'll see here is that we're calling a mutating function in the middle of UI layout, which maybe isn't the smartest thing to do. But eGUI doesn't have an opinionated approach to this. So you can really do whatever you like, whenever you like, and it might be something to consider, that you might want to be a bit more structured about how updates occur. And many of the UI frameworks that I mentioned, that part of the experimentation they're doing is trying to think about state management. And I think eGUI maybe has made a bit more progress on other fronts by essentially skirting the issue completely and saying, it's up to you, do what you will. Then we're going to throw some widgets on the screen in a vertical stack. And in the slider logic, we see Well, we're just setting up some properties here. So we're getting the range of the slider, we're adding a formatter, we're adding a parser, and we're going to add a unit to the value if one is needed. And the thing to get used to here, took me some getting used to, is that this is happening on every single update, and you just have to be used to that. My intuition about performance doesn't really apply because we're in the UI, and it doesn't matter unless your profiler tells you it matters, and you just have to be used to it. Then in response, if we have it to process a channel, then if the response it's declaring that the value has changed, so if the slider has been adjusted in the course of laying the UI out again, then we can send the latest value to the processor. The scope, here we have to give it some size. And by the way, I'm showing you this code just so you get a sense of a feeling of what it's like to work with the framework. It's not like we have to understand all of this in detail. I'm just kind of trying to give you a sense of the style of coding when you use the framework. And for the visualization, we have some points that we've received. We received an audio buffer from the engine. We've converted it into 2D points on the scope. And then we're going to give the point some color and then draw a line segment using this painter thing, which is much like any canvas-style rendering API you'll have seen before. So that's pretty much it for the eGUI example. And just to point out that it is cross-platform. This is the Freeverb app running on Android and on iPhone and on the web. And this is using an audio worklet, and the whole thing's compiled to WebAssembly, and eGUI renders to a canvas. And as a plugin. So I think to compare to another framework is worthwhile. And so then the other framework we'll look at in this talk is Dioxys. And Dioxys is an app framework which is evolving rapidly and becoming quite impressive. It's using the web stack, so it's a bit React-ish, but it's using Rust as the language for generating the DOM changes. And it uses the OS-provided web view. So rather than bundling Chromium like Electron, it's using the system web view by default. But the approach to the project is to be renderer agnostic, and a native renderer is in the works, which is extremely useful for audio applications, where, especially if you want to do real-time visualizations and you don't want to be serializing your data into the web stack. And they've put tons of effort into tooling, so it's very friendly to use and very easy to use and get your app running on all kinds of platforms. They have a custom command line tool for building, running, bundling your app for different platforms, and especially nice is hot loading of assets. So any images or CSS, this all gets hot loaded. Also the UI logic that you write in their special macro, which we'll see in a second, that all gets reloaded. And then very recently, they've added experimental support for also hot patching your Rust logic. So the pieces of the app which are not assets or in this special macro, but just general Rust code, now can be dynamically swapped into the running application using some fancy tricks that they've developed. So this is the Dioxys version of the Freeverb app. Missing from this is the real-time visualization, and there are details to this that, if there's time and interest, I can go into. But for now, we'll just leave it as read. That I would hope that, if I was to do this talk a year from now, I would imagine it will be possible thanks to the native renderer. But it's still very early days for that. To see how the framework feels to use in code, we have another main function with another like simple launcher thing. In this case, with like the specification that the like window configuration only needs to take place on the desktop, and then you might have other configuration instructions for other platforms. And then we launch with an app, and in this case, the app is a component rather than like a general like struct. This is a like a special, React-y sort of thing where you have a component that gets inserted into the UI tree. And the component macro at the very top there is generating a bunch of wrapper boilerplate for you. All you need to do is put on component, and then it does the work of making this usable within the Darksys runtime. So we have an app function that returns an element. And the general method for managing state is through using signals, and you get different kinds of signals. And I think if you've used React, you should be familiar with some of this kind of like this approach to development. So you have a hook which is run on the first time the component is initialized. So we're going to get our parameters. We're going to create a signal which is whether or not a Boolean of whether or not we're running the audio stream right now. That signal is then used as the source of like updated values, and then we can derive other signals from that. In this case, we're using use memo to say that we're deriving a signal, and we say that when audio is enabled, then we're going to construct our audio stream, and if it's not, then we're going to get rid of it. And it's like worth highlighting that audio enabled there is like a reactive hook on that signal. So whenever that value changes, then the audio stream initializer will be rerun, or it'll be destroying the audio stream. You get the idea. Then we're also going to derive another signal, which is if we do have an audio stream, then we want to get access to the processor, the to-processor sender, so that the parameters can start sending values to the processor. Then to lay the UI out, we have this macro that I mentioned earlier, RSX, which is basically HTML in disguise. You're able to insert like divs with classes and apply styling. So here we're importing some CSS, and this is like an asset which I mentioned earlier gets hot-loaded when you change it. You have like a header div here where we have like a big label, and then we have our audio-enabled toggle switch. And interesting here is that the pressed state of the toggle is reading the latest value from that signal that we built earlier, the Boolean signal. And whenever that changes, then the system knows that this toggle needs to be re-rendered. And on press change, this is the callback for when the value changes. And in this case, we can write a new value into that signal, and then that will trigger all of the listeners to the signal. Then we have our widgets again. And here we're passing in the particular parameter that the widget's attached to, and the to-processor sender channel. So then a quick look at how the slider is implemented. You have the parameter, you have that signal. In this case, we're declaring that it's a read-only signal, and you can see the type of it here is like optionally a to-processor sender. We're going to have a new signal just for this component, this slider, that is based on this parameter's value. And as a side effect or an effect on that signal, whenever that value changes, we're going to send the latest value to the processor. Then UI layout, similar to before. And here we have the slider's value reading from that signal. And when value changes, we're going to write into the signal so that then that triggers the effect of sending the value to the processor. So it's here it is running on the web and on Android. And here's a video, which is, oh, no, can we get that going? Let's see, it kind of looks like it's at the end. Be nice to be able to rewind that. Okay, here we go. So at the bottom of the screen down here, is that going to run? Okay, here we go. So we can't see all of it, which is a bit annoying, but that's okay. Down at the bottom, you've got the DirectSys runner, and we've launched the app in like the emulator to the right, making changes to the CSS that get applied immediately. And then here, you can see that like changing like the logic that derives the value string gets hot patched into the running app. And maybe this is really basic, I don't know, but to me this was very impressive that this is not only just an app, but it's running inside the emulator, and the runner is doing all of the work to make that work. And I don't know, I found that pretty sweet. I don't know, maybe I can play that again. I think it was quite fast. So yeah, changing some CSS, making it look great. And then you'll see in the app, in the top right-hand corner, hot patching, and this is where it's letting you know that it's stopping things for a moment while it swaps in your new logic. Anyway, I think this is very cool. So the work that I've done here is all available online. I've called it Imaginatively Audio App, and it's hopefully useful as an entry point for learning about like Rust or about these UI frameworks. And if you're interested in comparing these frameworks, you can dig a bit deeper into what it feels like to play with them. I also have examples running for Iced and Visia, which are popular UI frameworks for audio plugins, but kind of cut for time, but they're there and you can try them out if you like. And contributions are very welcome if you dig into it and you find a bug or you find something that could look better or be explained better in the comments or whatever. Like it'd be very happy to receive pull requests. So yeah, if there's a framework that you wish was in there, then please go ahead and implement it, and I'm sure you'll find some bugs. Some closing thoughts. I think that Rust and audio dev is coming along very nicely. And it's fair to say that full stack cross-platform Rust music app dev is now possible, but with plenty of rough edges, and not something I would necessarily recommend as a starting point. You're going to need to like get your roll up your sleeves and maybe write some code for frameworks and make some pull requests and things, but it's certainly possible. And I think it's also fair to say that things are improving very quickly. So I wouldn't have been able to give this talk a year ago, not to the same degree. Like DirectSys wasn't nearly as advanced as it is now. eGUI's mobile support wasn't really there a year ago. Things are rapidly improving. And I would say that the more the merrier is very much true. It's mostly a community of hobbyists. There are some companies making use of Rust, but not so many. A lot of the core crates that are used widely in the ecosystem are like community-driven and open source and maintained with love. Like the more people who get involved in this, the better. And if you feel like it could be an interesting language to work in, then a good place to start is the Rust audio community. They have like an active Discord and lots of projects on GitHub to look through. And if you have a budget, and I'm sure some of you watching this talk do, then please consider sponsoring some of these open source projects. There's a huge amount of work that goes into them, and it's often unrewarded, and some budget would go a long way. Let's put it that way. So thank you very much for your time. Very happy to be giving this talk. And yeah, there should be enough time for some questions, I think. But thank you.